Hello, I'm Professor Von Schmohawk, and welcome to YU. In the previous two lectures, we introduced logarithms. We saw that the base of a logarithm, which we will call b, can be any positive number other than 1. We also saw that to evaluate a logarithm, we ask what exponent would the base need to have to be equal to the logarithm's input variable x. For example, if the base of the logarithm is 10, and x has a value of 1000, since 10 cubed is 1000, the log base 10 of 1000 is 3. However, let's say that we would like to find the log of 1000 with a different base. For example, what would be the base 2 logarithm of 1000? Scientific calculators can typically calculate logarithms with a base of 10 or e. However, we may want to find the log of that number with a base other than 10 or e. In that case, we can use what is called the change of base formula, which can calculate the log of a number for any arbitrary base. In this lecture, we will see how to use this formula to convert the base of any logarithm to any other base. The change of base formula consists of 3 terms. The log base b of x is the log of x that we will calculate with the new base b. The log base a of x is the log of x with the old base that we want to change. And the log base a of b is the base a logarithm of the number b. As an example, let's change the base 10 log of 1000 to the base 2 log of 1000. We will start by filling in the values for a, b, and x. A is the original log base that we wish to change, so in this example, a is 10. The subscript b is the new log base 2, and x is the logarithm's input variable 1000. So we can now use this change of base formula to convert the base 10 log of 1000 to the base 2 log of 1000. We know that the base 10 log of 1000 is 3 since 10 cubed is 1000. And most calculators with a log function can tell us that the base 10 log of 2 is approximately 0.301. 3 divided by 0.301 is approximately 9.966. So using the change of base formula, we have converted the base 10 log of 1000, which is 3, to the base 2 log of 1000, which is approximately 9.966. As one last example, let's convert the base 10 log of 1000 to the base 3 log of 1000. So once again, a is the original log base that we wish to change, so a is 10. The subscript b is the new log base 3, and x is the logarithm's input variable 1000. So we can now use this change of base formula to convert the base 10 log of 1000 to the base 3 log of 1000. We know that the base 10 log of 1000 is 3, And most calculators with the log function can tell us that the base 10 log of 3 is approximately 0.4771. 3 divided by 0.4771 is approximately 6.288. So using the change of base formula, we have converted the base 10 log of 1000, which is 3, to the base 3 log of 1000, which is approximately 6.288. So far, we have seen many ways in which logarithms are used today. We saw that logarithms were initially developed in 1614 by Scottish mathematician and physicist John Napier as a means of simplifying tedious calculations involving multiplication or division. Using Napier's logarithm tables, multiplication and division involve only the much simpler process of addition or subtraction. In the next lecture, we will show how the slide rule was initially developed as a mechanical analog computing device that used this feature of logarithms to allow quick calculations without tables. Understanding how slide rules work gives us an intuitive understanding of how logarithms convert multiplication and division into addition and subtraction.